Welcome to Study Loop.
Hi there. So for this problem, we are given the function of a potential of electric potential, and there are some constants, and we need to determine it by the information given in this table. So the first thing that we can obtain is the constants A, B, C, and D with that given points, and then with the electric field, we can calculate the constants L, M, and N. So the electric field, or the vector of the electric field, is defined as minus the partial derivative of the electric potential in each component. So that when we obtain each of these components, this is at S, this is at Y, and this is at theta. So it will be that the S component is minus potential. So we can see in the function for the electric potential that when we partially derive that, only the first term is the one that we are going to derive with respect to x, because the other ones are just constants. So we will have minus a of x else over x. A is a constant and can be taken out of the derivative, and we will have the following: minus L a x L to the minus x to L to the minus 1. So this is for this first component. So for the other component, something similar happens. And this, in this case, is bym over s. So this will be m b y, sorry, y in here, y minus L. And for the seated part, again, something similar. Minus that part. So it will be minus and C theta and minus 1. So with this set, we can start by obtaining the values of the constants A, B, C, and D. So to find that, we first use the electric potential. So we evaluate the electric potential at the first point, which is 0, 0, 0. So the electric potential is 0, 0, 0. As you can see, looking here, that will give us all these terms are 0, and we are left with D, because I'm going to put it like just explicitly 0 m plus c and 0 and plus d. All of these is 0, so we will have that d is equal to the value of the potential at this point, which is 10. We can see it in the table. So d is equal to 10. So we have obtained the first constant. D is equal to 10. Now, also this should be voltages. Now we use the second point to find other variables, other constant. So in this we'll have 1, 0, 0. 0, 0. And we will have that for that point, the electric potential is 2. So this should be equal to 2. And putting those values, we will have A 1 to the L plus the other terms are 0 and plus D, which is 10 volts. Remember that this is 2 volts. So 1 elevated to any number is 1. So just A is equal to 2 volts minus 10 volts, which is minus 8 volts. So this is the constant A. So we do a similar procedure to find the other constants. We use now this point, which has a value of 4. So 0, 1, 0, 4 volts. So in this case, the only term that survives is B to the 1 to the M plus D, which is 10 volts, so that B is equal to minus 6 volts. And okay, let's keep going. So this is B. Now finally, for 0, 0, 1, we will have a value of the electric potential of 6 volts. So that this should be equal to the only term that survives. It's B. 1 to the N. This is 1 plus 10 volts. So C is equal to minus 4 volts. And then we just have obtained all these values. And now we can set that as far as now we know that the electric potential is minus 8 volts adds to the L. Well, also we'll have B, which is minus 6, adds to the L, and minus 4 volts adds to the N. So now we need to find the values of the constants L, M, and N. And for that, we will use the values of this table, but for the components of the electric field, which are this in here. And we already have what are the expressions for each component. So for E, for the X component of the electric field, we will have this in here, minus L AX to the L minus 1. We know that this is in the point 1, 0, 0. Since this only depends on X, we're gonna put it in here. We already evaluated this in the point 1, 0, 0. So this will be minus L A 0 L minus 1. We know the value for A, which is minus 8. So with this minus cancel, so we will have 8 L equal to 14. That's the value in here, 14. So if we solve for L, we obtain 14 over 8. We can simplify this and we will have 7 over 4. So this is the value for L. And now to find the value for the other exponents, we have for the y component of the electric potential minus b, evaluated in 0, 1, 0, 0, 1, 0, we will have that this is minus m b, and evaluated in 1 because it only depends on y and the y component, and this is n minus 1, this is 1, and this also should be 14 because that's the value of that component in at that point. So we will have 14, and we know the value for b, which is minus 6. This is minus 6 with this minus cancel, so we will have this should be equal to 6m. So m is equal to 14 over 6. That can be simplified as this, 7 over 3. And similarly for the theta component, we'll have the disability in 0, 0, 1. This will be minus n c 1 n minus 1. This is 0, so we will have that again. If we go to the table, again is 14, the value of the electric potential at that point. So we will have 14. And we know the value for C, which is minus 4. So this is minus 4, again with the minus sign cancel. So we will have 14 is equal to 4, so that n is equal to 14 over 4, which we can simplify as 7 over 2. So these are the values for L, N, and M. So we can just substitute that into the electric potential function, and we will have this in here, but with the values that we just have obtained for L, M, and N. So it will be minus 8x to the L, which is K, and L is 7 over 4 minus 6 volts x to minus 4 volts x to 7 over 2. And for the electric field, we will have for the this is a vector, so we will have for the x component will be this term in here, so we will have minus 7 over 4 8 volts x L minus 1 x 7 over 4 minus 1. For the y component, we'll have minus m and we know that m is 7/3 minus, oh, in here is -2 and -6 volts, x 7/3 or -1. Oh, this is y. Sorry, this is y. And for the theta part, we will have -7/2 minus 4 theta. So this will give us, simplifying, the following. This expression for the electric field. So part B of this problem, I don't have more space in here, but the final is to obtain the magnitude of B and the magnitude of E at some given point 0, and so there are 3 points. So gonna like make some space in here. So it will be for the first point. First point is 0, 0, 0. So that this is part B of this problem. So for this point, we will have, if we put 0, 0, oh, I almost forget, in here we have plus 10 volts of the d constant. So we will have that if we put 0 in all of these are 0, and we obtain 10 volts. For the electric field, if we put 0, 0, 0, we can see that that will be 0. And well, this is a vector, 0, 0, 0. And if we take the magnitude of that vector at that point, is just 0. Now at the point 0.5, 0.5, 0.5, that will be, you need to put all of those values in here. So it's something a little 0.5, 0.5, 0.5. So it will be -8, 0.5 to the second, -6, 0.5 to this, -4, 0.5 plus 10 volts, and this is, if we put all these into the calculator, 6.08 volts. And you did the same procedure for the electric field and for the other given point, that is 1, 1, 1. So for that point 1, 1, 1, I'm gonna like erase this. So for that point 1, 1, 1, point 1, 1, 1, 1, it will be want, 1. This will be -8, -6, -4 plus 10. So this will be -8 volts at this point, and the electric field at that point will be minus 111. It will be 14, 14, 14, 14. If you take the magnitude of that vector, it will be 14 because it is the sum of the square of each. Oh no, it will be, let me put it in here. It will be the magnitude, it will be the squared root of 3 times 14 to the squared, so that will be 24.2. And this is the values for the electric potential at different points. Thank you.